YouTube channel. Myself, Ravi Kumar. Please subscribe our channel and share to your friends also. Then, in this video, I am discussing about the very basic laws which are very useful in solving the electrical circuits problems. That is, Kirchhoff's voltage law (KVL) and Kirchhoff's current law (KCL). In first, that what is meant by KVL? That is Kirchhoff's voltage law. What is the statement? That is, it states that the algebraic sum of the voltages in any closed path is zero. That means total voltages in any loop or in any closed path is zero. That is KVL. For example, we can verify that the statement. That is, you have to consider three elements, that is resistance R1, R2 and R3 are connected. For example, in case of series connection, all elements are to be connected to a single voltage source. For example, we consider this is R1 element and second R2 element and third R3 element. Then consider we have taken the voltage source is Vs supply source. Then the passing current we are taken as I. We can verify the KVL rule. That means what according to property of resistance, whenever a current is passing through resistance, what happened? Always you can take the direction of the current through the elements is from higher potential to the lower potential, as well as for the source, the current can be passing from lower potential to the higher potential. That is, for elements plus to minus, for the sources minus to plus. Okay. Then, according to the property of the resistance, whenever a current is passing through resistance, what happened? A voltage can be dropped across the resistance. For example, we are taken as for R1, we are taken as VR1. For R2, we are taken as VR2. For R3, we are taken as the voltage drop VR3. Then apply KVL. According to KVL, what is law here? Then the current is flowing from the source minus to plus, that is lower potential to the higher potential. That's why we are taken as plus voltage source value. Similarly, the current can passing through the elements from higher potential to lower potential. For that case, we are taken as the voltage will be negative, that is minus VR1. Similarly, for R2 also minus VR2, and similarly for R3 also minus VR3. That means the total voltages in a loop is zero. That is the statement of the KVL. It is a form a closed loop R1, R2 or resistance, then all voltages will be zero. That means Vs equal to supply voltage is equal to the sum of all voltage drop in series circuit. That is Vs equal to VR1 plus VR2 plus VR3. What I mean that here? That means the series circuit, it is a series circuit. The series circuit can be acting as a voltage divider. That is, a voltage can be taken as a divided circuit. That is, voltage will be divides. That means the total voltage Vs can be divided into three parts. We have three elements. That parts are VR1, VR2, VR3. That's why the series circuit can be acting as the voltage divider circuit. This is the statement of the KVL. Suppose, for example, we know Ohm's law. Then, according to Ohm's law, what is the value of VR1? That is V equal to IR, the voltage drop across resistance. That is I into R1. Similarly, VR2, that is I into R2. Similarly, VR3, I into R3. Then I will be common here. Then total resistance in series circuit here I into R1 plus R2 plus R3. From that, we have to calculate the total current in this circuit is total voltage by then total resistance, that is adding of all elements, because it is a series circuit, that is I equal to V by R1 plus R2 plus R3. Like that, we have to calculate the total voltage drops across each element. Then we have to verify the KVL rule also. That means consider we have a series circuit. For example, we are taken as two elements. For example, then that two elements are connected to a voltage source. Are connected to the voltage source. Then we are taken as that voltage source value is suppose 20 volts, and first element is 5 ohms and second element is 2 ohms, and also we are taken as R3 also, for example. Okay, like that above some circuit we are taken as R3 also. That R3 value we are taken as 4 ohms, 5 to 5 ohms, 2 ohms and 4 ohms. Okay, now then how to take as current direction? Always you can take the current direction is for the source from minus to plus and elements from plus to minus. That is, you have to show like that the loop current will be taken as I. Okay. Then from the above equation, then how to find out the current value? Already you can derive, that is I equal to total voltage 20 by and total resistance 5 plus first element is 5 plus 2 plus 4. Then the total current value will be here 1.82 amperes. Current can be, the units of current is amperes. Okay, 1.82 amperes. In like that, we have to find out the loop current. Then after finding the loop current, then what is the voltage drop across 5 ohms? That is V5. Then what is formula? V equal to I into R. Then R value 5, I value is I. Then 5 into 1.82 equal to, what is the value here? This value is 9.1 volts. Similarly, what is the voltage drop across 2 ohms? That is taken as V2. Similarly, we have to find out 2 into 1.82. 2 into 1.82. That value is taken as 3.62 volts. Then similarly, V4, the voltage drop across 4. Then you have to calculate the value is 7.28 volts. Then here you can apply KVL. That means sum of the total voltages, that is V5 plus V2 plus V4. We have to find out that. That is V5 plus V5 plus V2 plus V4, that equal to, then already we know the value of V5, that is 9.1 plus 3.62 plus 7.28. You can add all voltages, you will get 20 volts. What is the 20 volt source value? That is called the total voltage source value, that is Vs. Okay, that's it. What is the KVL? That is Vs equal to V1 plus V2 plus V3. That is that VR1 plus VR2 plus VR3. That's why the total voltages in a loop is 0. Hence, then you can write down, hence KVL is verified. Okay. Then in like that, you can apply the KVL rule to find out the voltage drops and to verify the KVL law also around a closed path. Okay. Then second law, that is taken as KCL, that is Kirchhoff's current law. What is the statement of the KCL? That means at any node, you can take node point is the where current division takes place in the circuit, that is taken as the node. At any node, total currents passing through the node is zero. That is, some currents are entering and some currents are leaving from that node. That's why KCL statement says that sum of the currents entering into the node is equal to the sum of the current leaving from that node. That is the statement of the KCL. Okay. For example, we can take a parallel circuit. KCL you can apply for in case of parallel circuit, and similarly KVL can apply in case of series circuit. Okay. For example, here you can consider a parallel circuit, that is you have taken two elements, or in case of parallel, that is two elements, or in case of parallel, then that two elements are to be connected with a voltage source V. Then you can take the total current value. Okay, that is the current coming from the source. It is taken as I. Then similarly, the current passing through first element is I1. The current passing through second element is I2. The first element is R1 and second element is R2. Okay, here at this node, current will be takes division. That's why it is taken as the node. Then, according to KCL law, what is sum of entering current? Entering is I equal to sum of leaving current. Leaving currents are I1, I2. That is I equal to I1 plus I2. Then, what is the I1 value here? It is a parallel circuit. In parallel, voltage is same. That is the voltage across R1, the voltage across R2 is same. That is supply voltage V. That's why I equal to formula is according to Ohm's law. I equal to V by R. That means V by R1 plus, that is V by R2. Then take LCM on both sides, that is R1, R2. Then V is common. Then on the numerator we have R1 plus R2. Okay. Then here already we know the value of V. That is, suppose we take as voltage drop across R1. That is I1 into R1. Then R1 plus R2 by R1 into R2. Okay. Then on numerator, denominator, R1 will be cancelled. Then what happened from that equation? Then what happened? What is the value for I1 from the above equation? That is I1 equal to total current into R2 by total resistance R1 plus R2. Like that, you have to find out the parallel current I1. Okay. Simply you can remember that is this is called the current division rule. Okay. That means if you find out one of the branch current, then you can take total current into opposite value by total resistance value. For example, we know total current is I. Then if you find out the current passing through R1 I1, then opposite value, that is R2 by total value R1 plus R2 into total current into I. Okay, like that. If you find out another branch current, that is I2, then what happens? Same formula I. Here we find out passing current I2 through R2. That's why opposite value R1 by R1 plus R2. Okay. In this way, you can apply current division rule. Then you can find out the current passing through the branch currents. Okay. That means, for example, here you can verify the same KCL by taking the example. That is, for example, consider one circuit, that is, it is having two elements, both are connected in parallel. That means you have taken the supply voltage here. That voltage is taken as 20 voltage source. First element is taken as 5. Second element taken as first element 10 ohms and the second element 5 ohms. Okay. Then we have to find out, apply, verify KCL. That is total current taken as I. Then this branch current taken as I10. This branch current taken as I5. Then apply KVL. Okay, na? Then first of all, we can find out total resistance. Okay, na? Both values are in parallel. For parallel, what is the formula? That is R1 R2 by R1 plus R2. This is the total resistance value. This value is 3.33 ohms. We know total resistance of the circuit. Then find out total current. That is total voltage V by R. I equal to V by R. Total voltage V and total resistance is 3.3. This current value is 6 amperes. Okay, you have to verify KCL. Then you have to find out the branch current. First branch current, that is I10. Okay, you have to find out first branch current, that is I10. Okay, that means the value of I10. What is the formula? We know total current into opposite value, that is R2 by R1 plus R2, that is 10 plus 5, 15. This value is 2 amperes. Similarly, you have to find out I5. That value taken as same. Total current into opposite value 10 by and total resistance value 15. That is 4 amperes. Okay. From these two values, that is I10, I5, that is I10 plus I5. That is what value? 2 plus 4, 6. What is 6 value? That is total current. That's why sum of the leaving current is equal to the sum of the entering currents. Okay, like that you can verify Kirchhoff's voltage law as well as Kirchhoff's current law, KCL as well as and KVL. Okay, please subscribe our channel and share to your friends also.